To solve this data sufficiency question, we'll go ahead and consider each statement separately first and then together if needed. Before diving into the statements, let's go ahead and take a look at what the question is asking. If x is an integer, is x minus the absolute value of x less than 10 to the x? Now this looks a little intimidating, but let's not go ahead and let's not get overwhelmed by this kind of messy looking inequality. And let's dive into our statements. Remember, we're just asked whether this inequality holds, whether it's true or not true, essentially. And if we can find a definitive answer given the statements, then the statement would be sufficient. But if we actually can't come to a conclusion with the statements alone, we might have to consider them together. So statement 1 tells us x is equal to 0. So we can actually go ahead and just take our inequality and let's plug in 0 and see if it's true. So taking our inequality, we actually have that 0 minus absolute value of 0, and we're kind of considering, is it less than 10 to the 0? And we're trying to figure out whether this is true or not. So just simplifying a little bit, absolute value of 0 is going to be 0. 0 minus 0 is 0. And is that less than 10 to the 0? Well, anything to the 0 power is going to give us 1. So 10 to the 0 is 1. And this is actually true. So yes, this is actually true. And that means that we can definitively answer the question. If x is 0, then yes, this is actually true. And this statement alone is sufficient. That means our answer choice is either A or D, so we can eliminate B, C, and E. Now the choice between A and B and D kind of depends on what statement 2 does. So let's go ahead and let's take a look at statement 2. Statement 2 tells us x is less than 0. So this is going to be a little bit more work since it's not a definitive value. We can pick some values and plug them in if we want. We would probably want to test about 2 values just to make sure that we're getting kind of consistent results from that. So that's one option, is to pick a couple of values and go off of consistency in terms of a pattern, if that inequality would be true or not. And that might be the fastest way to go about doing this. There is an alternative way that we can do this abstractly as well, which is also kind of fast. So we'll do this abstractly since we can always plug in numbers. If x is less than 0, that means that x is some negative number, let's say like x times b, where b is a positive number. So this just kind of accounts for that our x is going to have a negative sign with it, and our b here would be positive. So if we take our inequality and let's check it again, kind of like we checked our statement 1, and just plug this right in. So x would be a negative number, so negative b if b is our positive number, minus absolute value of negative b. And we're checking, is that less than 10 to the negative b? I'm going to slide down a little bit for more space since we have our inequality we're working with. And let's simplify. Absolute value of negative b is just going to be b because the negative is going to drop. So we end up with a negative b minus, because the minus sign here doesn't change. Order of operations, we do the absolute value first. So minus b less than, and we're kind of still checking whether this is true or not. We don't know. 10 to the negative b, and negative powers essentially are fraction values, and we could bring that to the denominator of a fraction, so 1 over 10 to the positive b. Now remember, b is positive. So this actually gives us, sliding down a little bit more, negative 2b is less than 1 over 10b. And if we think about whether this is true or not, b is any positive integer. So any positive number times a negative 2, that's definitely going to be negative. And 1 over 10 to the b, 10 to a positive number is going to be positive. 1 over a positive number is also going to be positive. So this is essentially asking us whether a negative is less than a positive, and that is definitely true. So yes, this inequality does hold, and our answer to the question would be yes. So we would be able to go ahead and choose our answer choice. Statement 1 is sufficient, statement 2 is sufficient. So our final answer choice would be answer choice D, and we can eliminate answer choice A. So let's actually just go ahead and look at the alternative option for checking statement 2. Because kind of depending on what you're comfortable with, choosing values for our x in statement 2 might be a little bit faster than doing it abstractly. So I'm going to scroll down a little bit and let's go ahead and let's clear our statement 2 work, and let's redo it using kind of the alternate method of choosing values for our x. So if we were to go ahead into statement 2, kind of retrying it, we're told that x is less than 0, so we can pick test values if we want as an alternative option. So the first value we would probably pick would be a nice easy value like -1, something like that, and we plug it into this inequality and see if it works. So -1 minus absolute value of -1, absolute values look like 1s, is that less than 10 to the -1? And if we simplify this a little bit, we'll have a -1 minus +1, and is that less than 10 to the -1? And simplifying this, we end up with a -2 is less than 1 over 10. And that is true. But typically, just because one option works doesn't mean that all of our options work. And we would want to choose another value. Now, typically when we're picking values for these test value cases, I'm just going to jot down, remember that our condition is that x is less than 0. Typically, we want to consider all kind of different scenarios when we're doing this. We want to pick values, integer values that satisfy our condition. We also want to consider fraction values because sometimes those can trip us up. Positives, negatives, zeros can also trip us up. For our case, we don't have to worry about 0. We don't have to worry about positives because they're not in our range. But we do want to consider a fraction value because that might throw off are things that are going on. So let's consider -1/2, just because it's slightly different kind of structure than a negative integer. If we pick -2, we might get the same pattern any integer value we already picked, kind of similar to -1. So we'll have a similar pattern happening here. So let's just double check a different type of value that's included. So plugging this into our inequality was our x minus absolute value of x less than 10 to the x. So we end up with a -1/2 minus absolute value of -1/2. Is that less than 10 to the -1/2? And we just want to kind of figure out whether this would hold. So -1/2 minus -1/2, or minus a +1/2 because we're taking the absolute value. Is that less than 10 to the -1/2? And scrolling down a little bit for more space, we end up with -1. Is that less than 1 over 10 to the 1/2? Now, even though we have a fraction exponent, this number is still positive. That means the quotient here is still positive, and this would be negative. So negative is still less than a positive, and this actually inequality would hold. So doing these kind of picking values, it doesn't necessarily mean that we proved it for all of the values, but if we notice a pattern, we can definitely conclude that this statement would be sufficient as long as we kind of tested all the different kind of things that can happen, the different types of numbers that can happen. So this statement would be sufficient just by kind of trial and error here if that's a little bit easier for you. So answer choice D would still be our answer choice. Both statements alone would be sufficient.